Hi there, Mr. Sutton here, bringing you the Algebra 2 4-4 Part 1 homework solutions on factoring polynomials. In this one, we are focusing on greatest common factor and factoring by grouping. For this problem on factoring completely, we first want to check to see if there's any common factors we can take out of the original expression here. So it looks like the 3 and the 48 are both divisible by a 3. So that's the constant common factor. And then the lowest exponent here is y to the third. So we can take a y to the third out of everything. So 3y to the third, 3y cubed. Coming out of 3y to the fifth, 3y to the fifth divided by 3y cubed is y squared. And negative 48y cubed divided by 3y cubed is going to be, let me think, negative 16. Now once you've taken out a common factor, let's double check and see if we can factor the leftovers a little bit more. Y squared minus 16 is a difference of perfect squares. So we can factor that using the a plus b, a minus b shortcut. So we have the 3y cubed we initially took out, and then the square root of y squared is y. Square root of 16 is 4, so we have y plus 4 and y minus 4. For this problem, let's start by seeing if we can take out a common factor. So there's no constant common factors other than 1, but these all have at least an x to the first power. So let's take out an x. That leaves me with x squared minus 2x minus 24. And now can I factor the leftovers a little bit more? Well, what are two things that multiply to negative 24 and add up to negative 2? Let me think. 1 and 24 doesn't work, 2 and 12 doesn't work, neither does 3 and 8. But 4 and 6 works, positive 4 and negative 6. So we've got x plus 4, and we have x minus 6. For this problem, as always, we are going to see if we can take out a common factor before we do anything else. So 3, 11, and 20, there's no common factors with those numbers other than 1. But for the exponents, we have an r to the fourth power. That's the lowest exponent, so I can take that out of all of the terms. So if I factor out an r to the fourth, that leaves me with 3r to the 6 minus 4, so r squared, minus 11r to the first, minus 20. And now the million-dollar question is, am I done? Or can I factor the stuff inside here a little bit more? Well, since we have a 3 instead of a 1 in front of the squared term, if I can factor this, I'm probably going to have to use either guess and check or the AC method. Let's try the AC method. So 3 times negative 20 would give me negative 60 for my AC value, and then we would be looking for numbers that multiply to negative 60 and add up to negative 11. 60's got a lot of factors. Let's go through those. We've got 1 and 60, which will not work. 2 and 30 doesn't give me 11. 3 and 20 is a little bit closer, but still not what I need. 4 and 15. Well, positive 4 and negative 15 adds up to negative 11. So I can split this up into a plus 4r minus 15r. And now that I've done that and split this up into 4 terms in here, I can use factoring by grouping to go the rest of the way. So I've got the r to the fourth that I initially took out. I can't lose that because that's part of my factorization. But now the first 2 terms in here, using my factoring by grouping technique, I can take out an r from both of those. So that leaves us with 3r plus 4. And then for the last 2 terms, these are both divisible by negative 5. And that's about it. So if I take out that negative 5, that leaves me with a 3r and a positive 4, which is thankfully the same thing that I got in the other parentheses. So I've got the r to the fourth. I'll bring that down again. And now 3r plus 4 is a common factor that can come out of everything. And finally, we have the leftovers, r and minus 5, going in a parentheses next to that. So that is fully factored. On this problem, since I have 4 terms, at some point I'm going to try factoring by grouping. Let me just double check as always though and make sure there's no common factors I can take out right away. So we have a 2, a 20, a 5, and a 50. Nope, there is nothing I can take out of all 4 terms, so we go straight to grouping then. For the first 2 terms, we can take out a 2 and also a k squared. That leaves me with a k minus 10. And then for the last 2 terms, I can take out a 5. leaving me with a k and a minus 10. So we see that our common factor of k minus 10 can come out of all that. And then we have 2k squared plus 5. Now, can I factor this squared parentheses any more than I already have? It doesn't look like it. This is not the difference of two perfect squares. So if I have two terms and it's not that a squared minus b squared sort of setup, then I'm kind of out of options, and this problem is just going to have to be done the way it is. For this problem, we've got four terms, and there's no common factors we can take out of all four of them, so we're going to start immediately with grouping based off of that. For my first two terms, I can only take out an x squared, but that's better than nothing. So that leaves me with an x minus 8. For the last two terms, I can take a negative 4 out of both of those. So that's going to be an x and a, let's see, 32 divided by negative 4 is also negative 8, just like the other parentheses. Since I have the same parentheses, I can take out x minus 8 as a common factor. And then my leftovers, x squared minus 4, go in my other factor. Now I always have to check if I have an x squared to see if I can go a little bit further. So this is a difference of perfect squares. I can use the a plus b, a minus b shortcut on this. So I have the x minus 8 that I initially got, and then square root of x squared is x, square root of 4 is 2, so we have x plus 2 and x minus 2. For this problem, we've got four terms, and it doesn't look like I can take any particular thing out of all four of them. We've got a lot of q's, but not all of them. We've got things that are divisible by 4, but this 9 kind of breaks that pattern. So we're going to go straight to grouping in this case. For the first two terms, I can take out a 4 for the constants and a q squared for the variables. And that will leave me with a q minus, let's see, 16q squared divided by 4q squared is just going to be a minus 4. For the next two terms, I can take out a negative 9. That leaves me with a q minus 4, 36 divided by negative 9. Since we have a q minus 4 for both of those, that comes out as a common factor. And then 4q squared minus 9 is the other factor. Now the 4q squared minus 9, this is actually a difference of two perfect squares. So I can factor this a little bit further. We have the q minus 4 we already took out here, and then the square root of 4q squared is 2q. Square root of 9 is 3, so we can do this as 2q plus 3 and 2q minus 3.